another rate of change video. I think so. It's part 10. We have a sphere. We have a sphere, right? Or something looks like sphere. It's hard to draw on this tablet. Okay, what do we have? Given a sphere of radius r. Here we have radius. This is the center, and this is radius r, right? Suppose the radius of the sphere is increasing at the rate of 5 centimeter per second. So the r to dt, it's increasing at a rate of 5 centimeter per 1 second. That's good. That's good. The r 5 centimeter to dt 1 second. This is the rate. Part A, find the rate at which the surface area of the sphere. Oh no, sorry, this is part B. Find the rate which the volume of the sphere first is changing, and calculate this rate when r equal 2 centimeter and when r equal 3 centimeter. So we have to find the rate of the volume of the sphere is changing. So we need to find simply dv to dt, right? The rate for which the volume is changing. We need to find dv over dt. First, what is the volume of the sphere? It's 4 over 3 pi r cubed, right? What is the derivative with respect to r? It's because it's given and r, right? It's a function of r. So dv over the r is equal to 4 pi r square. That's nice. We need to find the volume of the sphere changing with respect to time. It's dv dr, right, times dr dt. That's great. Which is equal dv dr 4 pi r square times dr dt, which is 5 centimeters per second. So it's equal to 20 pi r square. We need to find when the radius is 2 centimeter first. For r equal to centimeter, this implies that dv dt is equal 20 pi r square, which is 20 pi 2 square, which is 2 square is 4 times 20, it's 80 pi. And since it's volume, it's centimeter cube per 1 second. And for r equal 3 centimeters, this implies that dv dt is equal to 20 pi r square, which is 20 pi, instead of r is 3 square, 9 times 20 is 180 pi centimeter cube per second. That's great. Let's go for part B. Part B says, part B says, find the rate at which the surface area of the sphere is changing. So surface area rate, we need to find the surface area of the sphere is changing is how much. Find the dA to dt, right? And calculate this rate also when r equal 2 and when r equal 3. First, what is area of the sphere? Area of the surface area of sphere is 4 pi r square, right? Area of the sphere is 4 pi r square. If we derive this formula according to r, because it's also a function in r, so it's 4 pi, it's constant. Let's say dr square to dr. This means dA dr, simply it's 2r, it's 8 pi r. Okay, now what is the chain rule for the dt? If I want to find the dt, it will be dv dr times dr dt, which is by given 5 centimeter per second. dv dr, we found it as 8 pi r times dr dt is 5. So I will finalize with answer 40 pi r. That's true. Now for r equal 2 centimeters, this implies that the dt is equal to 40 pi, right? Instead of 40 pi r, we can substitute instead of r its value, which is 2, and we finalize answer 80 pi. And it's an area, so it's centimeter square per 1 second, right? And for r is equal to 3 centimeters, this implies that the a dt will be equal to 40 pi r, which is equal to 40 pi times 3, that is 120 pi centimeter square per second, because it is an area. Let's go for the other parts. But we have to be careful here, because suppose the surface area of the sphere now is increasing at a rate of 10 centimeters square per second. So suppose that the surface area, suppose that it's given, the A over dt is changed 10 centimeters square per second, right? Let's find part C. Find the rate which the volume, let's say, find the rate which the radius is changing. Find the rate which the radius is changing. So we need to find dr dt. dr dt. What is that equals to? Okay, again, chain rule. Chain rule is the ADT that we have it is equal to the ADR. It's equal to the ADR, the ADR times the RDT, times the RDT. We need to find the RDT. Do we have the ADT? It's given. Okay, we need to find the rate of radius, how is changing. So the RDT simply is equal the ADT, right? The ADT over the ADR, the ADR. The ADT is given as 10 over the ADR. What is the ADR? It's 8 pi r, and we found it. The ADR, derivative of the area, according to r, it's 8 pi r, right? The ADR here is 8 pi r. That's nice. So that's the answer. That's the answer. 10 divided by 2, it's 5. 8 divided by 2, it's 4. So it's 5 over 4 pi r. And that's it. We don't have to change r here. He didn't tell me. Now we need to find the volume. How much the volume is changing, right? Let me go back to the question. Find the rate at which, yes, the volume is changing. This means we are finding dv dt. We are finding dv dt equals, what is that? All right, dv dt is equal to what? dv dt simply, it's dv dr, which we have it, times the r dt. Great. This implies dv dt is equal, right? dv dt is equal, what is the VDR? The VDR is 5 pi r, 4 pi r square. 4 pi r square. It's derivative of volume. It's derivative of volume. We found it before, right? The derivative of volume here, it's the VDR is 4 pi r square over times, I mean, the RDT. What is the RDT? The RDT, we found it in the previous question. The RDT, it's 5 over 4 pi r. And what is that? 4 cancel, pi cancel, and r cancel. So the final answer will be, it's 5r. Done.